I'm Christian Frank. I'm Professor of Atmospheric Science at the University of Birmingham. I have a broad interest of research. More recently, I've moved into trying to understand indoor air quality, which is a very important topic. It has only been recently recognized as a major challenge, largely caused by the COVID lockdowns, realizing that we spend so much time indoors, 80 to 90% on average for a UK population. And I think it's really amazing how little we know about the indoor air. How little we know about what I'm breathing right now, because in many locations, first of all, there are no measurements, there is no understanding how air moves in indoor spaces, and also there's very little regulations, especially in private homes.
We have become much better at insulating our environments, and this is a very nice thing, but by insulating the indoor environment from the outdoor, and kind of short-circuiting this connection, what we might be doing as well is keeping some pollutants that we produce indoors in the environment and not exchanging sufficiently. And we might be exposed to those pollutants more than we need to.
If we say that indoor air quality is a major public health concern, our built environments, the way we build, construct and use, that has led to increased concern. For example, we are building now buildings more airtight. So when we are building the buildings more airtight, it has an impact on ventilation, and that leads to the higher concentration of indoor air pollutants indoors. And then as we spend most of our time indoors, what it means that there is more likelihood that we are exposed to higher concentration of pollutants.
We cannot keep assuming that pollution or bad air quality in indoor environments is something inevitable. So there is an element of health inequality here, and again, the data are very clear on this. It's a stark contrast, even in developed countries like the UK. So that proves that there are material conditions we can act upon, and those have to do with environmental outdoors, of course, having more green areas, being less exposed to heavy traffic and so forth, but also with environment indoors.
This project is called the Indoor Air Quality Emissions and Modelling System, IAQ-EMS, which has been funded by the Met Office and UKRI. And it involves a range of scientists here at the University of Birmingham, but also at Cranfield University and Cardiff.
The Clean Air programme is part of a Strategic Priority Fund programme that the Met Office have been involved with for the last few years. And it's a very good research programme in that it allows us to approach developing solutions for environmental problems in a much more holistic fashion that has been done in the past. It's very important that because a lot of environmental matters are problems are multifaceted, and as a result, if you just home in on one small area of the problem, you tend to end up with unintended consequences. So the idea behind the Clean Air programme is to look really or approach developing the solutions in systems-led and holistic fashion.
This project has been really an eye-opener for me personally, but also learning more about the remaining challenges in indoor air quality specifically. So we've developed some outputs, but very clearly these outputs show that there are huge knowledge gaps remaining. The emission inventory has shown us that certain locations have been overlooked for measurements. So to get a full picture of what people are exposed to in the UK, we really need to measure in all relevant locations. In terms of the model outputs that we've developed, we have applied them to a very small number of locations. And we really would like these to be used by researchers to apply in different locations. Not a single project can address that. And then the multi-box model, we really would like practitioners to use more frequently. So I'm thinking about architects or city planners and councillors making decisions about, how is the city of the future looking like? Because it's really important to have an understanding of what impact do decisions have on indoor air quality. Because in the end, the exposure of people in new spaces should be minimal in terms of air pollution, and our models can really help to achieve that goal.